So part one, I'm going to do a simple little graph here, and I'm going to go up. I'm going to put a point here where it's 6 and 4. So this is a distance of 6, this is a distance of 4, and I'm going to go out to that point, and this is our vector. So the vector is a direction that we're going to. It's not just a point at a place, it's actually a direction. And there's usually a beginning point and an ending point, but it's going to that point. So it's not like just a line segment. If I didn't have the arrow there, we'd just have 0, 0, and 6, 4, and it would just be a line segment. However, it's usually a direction, and actually we'll count it as a direction here. So what we're going to do is we're going to find the distance here, and in the vector world, that's called the magnitude. So the magnitude is equal to that. When you see double absolute value lines, I'm not sure what else to call it, double absolute value lines, that's the mathematical symbolism for the magnitude. And what that means is you figure out a specific number, which is nothing more than the direction, than the distance there. So that means what we'll do is the distance is equal to x squared plus y squared. Or the differences between the x's. From 0 to 6, the distance is 6. From 0 to 4, the distance is 4. So that means it's going to be 6 squared plus 4 squared. 36 plus 16 is the square root of 52. Square root of 52 has a perfect square form in it, because remember what we have is 4 times 13. So we have 2 square root of 13. I will not accept square root of 52 as an answer because there's a perfect square in it. And I will not accept it as a decimal because this is not the real number. It would be rounded, and if you could round these distances, that would be okay. But you'll notice through all the questions in the textbook, they never round it. They always leave it in square root form if it is one. Okay, so we'll do the same thing. So you sort of take your cue from the way the textbook shows the answers. The way I show them and what I say in class, follow what I do. The way the textbook does it, follow what it does. Okay, so that's the format I want. Unless I specifically say on a test question, if I say I don't want a certain way, then do it that way. All right. So that's the exact answer, and that is the magnitude. So the magnitude for a vector, for the vector 0, 0 to 6, 4, the magnitude is 2. Now, the next part of this section, if you've gotten to it, you realize this is another one of those easy things, but I have found for some reason on a bunch of my tests in past years that this tends to throw people. So, sketch and find the magnitude of V equals 5I plus 2J. So what we're going to do here is to sketch it or graph it. So sketch simply means graph it, show where it is. And you just learned about making the magnitude, finding the magnitude, so we'll do that. So a sketch. All right. Let's do a little graph over here. And we'll actually need to go out to 5 units here. Okay. Oops, I made a little mistake. It's not a big mistake, but I made a little mistake. I guess I wanted to do it negative, but I don't need to. I was going to make it negative, but we might as well leave it positive because it really doesn't matter. So, plus 2. Because for sketching it, V equals AI plus BJ. Notice now we have I and J. For vectors, we use those letters to determine the X and the Y values here. The A is the X and the B is the Y. So we would graph that in the same way like we did with polar, when we took the X and the Y out with the rectangular forms of complex numbers. So we'll take the X and the Y, we'll take 5 and 2. So that means here, 5 and 2 is where this is. Now, the thing is, when it's in this form, it's from 0 going to here. So what's implicit with this is that it's what's called a position vector. Position vector is when you're going from 0, 0 out to the point. Okay. Arrow out to that. And B, the magnitude, okay, is the square root of A squared plus B squared. So 25 plus 4, that's 29, and that one cannot be, there's no perfect square in that, prime number, so we just stop there with the square root of 29. So what we've done here on this one is sketched it by using the 5 as x and the 2 as y, and then drew the arrow coming from 0, 0 from the origin, and we found that the magnitude is the square root of 29. So I could even come up here and say that the distance of this is square root of 29. Not required to do. Just saying, answering the question of what the
magnitude is like the radius.
Exactly. Sometimes you have a vector that's from 2 points and it's not the origin, so then it wouldn't be a radius. But here it would be. It makes complete sense thinking of it this way as a radius. Okay, now, and that leads in here. This is a position vector. When it's going from 0, 0 out to it, it has a specific name as a position vector. When it's not a position vector, you can make it one, and that's what I'm going to show you next. So the third thing here, when it is not a position vector, you can make it one. So let's take these 2 points, negative 1, 6, and P2 will be 7, negative 5. Unlike most of the things you've done in math before, it matters which one is 1 and 2 here. In the past, especially if we were doing just an x, y equals mx plus b, and you had 2 points, it didn't matter one bit which one you chose as part point 1 and point 2. If you were doing the slope, as long as you were consistent, it didn't matter. Here it does matter. This is telling you by saying point 1 and point 2 that this is your starting one, and the arrow is going to go to that one. So there's a specific direction. That matters when we make it a position vector, and I'll show you in a moment. So let's graph this approximately. Negative 1 and 6 is maybe about here, and 7 and negative 5 is, I don't know, give or take about here. That's a good enough estimate. I don't even need numbers. But I know negative 1 will be a little bit over here, and 6 will be a ways up. Positive 7 for x will be a ways over here, and then down here, but not quite as far as I came out for the 7. And because that one's 2, I have the arrow going to that second one. It's a vector. Because I said it was a vector, it's a vector. That's pretty much all you need for that. Problem now is that that's not a position vector because the starting point is not at 0, 0. On one hand, changing it to that is really pretty easy. I'm going to show you the formula for it, and you just have to be careful of one thing. But if you think about it, just like finding, when you do rise over run and back to linear equations, you can do the slope. If you need the slope, you can do the whole slope formula of y2 minus y1 over x2 minus x1. But if you have it graphed, it's much easier just to do rise over run. So one thing you can do here is move this point here by going down 6 and over 1. And then take this one and go down 6 and over 1. That would do the same thing. But, of course, I am going to show you the formula of what the textbook does. So what this tells you to do is that this vector is going to be, is equal to x2, so the x from the second pair, minus the x from the first pair, I, plus the y from the second pair minus the y from the first pair, j. So we'll get the vector name for this, for the position vector, the I and the j, by doing 2 minus 1 with this. So it's going to be the 7 minus the negative 1. So that means it's going to be equal to 7 minus a negative, which is 7 plus 1, which is going to be 8i. And then negative 5 minus 6, which is a negative 11. So it's going to be minus 11j. So now if I were to graph that here, I would use the 8 as x. I'd go over to here and I'd go down to negative 11. So I'm actually somewhere down about here. I'm going to go right through my plus sign. I should have written that down a little further. So that's where we're supposed to be. That makes sense. I took this and I just moved it down and over, and I end up somewhere about there. Now, watch something. And I would say for this, what I'm going to do next, don't write this down, because I'm basically going to make a mistake, and I want you to see it happen. Let's say instead of doing this pair first for these two, I do this pair. So in other words, I'm going to act as if it was going this way, but it's not. It's going this way because that one's 2. So let's say I did -1 minus 7, which is -8. And actually, I don't even need v equals -8i plus 6 minus a negative, or plus 6 plus 5 is going to be 11j. What that's going to do is I'm going to go over -8 and up 11. Okay. Well, it's like the same line. But what I'm really doing in this case, if I do it that way, what I'm doing is I'm taking this and moving it up and over as if the arrow was going that way. So now that's a position vector going this way. But that's not what this one is. This one is starting here and going this way. It's not going that direction. So the arrow, and being told by saying this is P2, means it's going this way. This is the position vector. This is not. So you have to make sure you get the order right. In this case, I had done 7 minus the -1. In this case, I did -1 minus 7. So if we were doing slope, y equals mx plus b, we get the same answer even if we flipped them. We don't get the same answer here, so make sure you don't do that. Okay, so watch out and make sure that you follow the order. So I'll just put a note here. The order of P1 and P2 matters. So as long as you got that down, you won't make a mistake here with the these things. Okay, that makes sense for this? You get it in the right order for it? All right. I don't want you getting that wrong on the test just because you did this one first instead of that one. Okay. The next two sections in the textbook are adding and subtracting vectors and doing scalar multiplication, and I am not even going to bother talking about those. Those you can learn on your own. Those are really pretty easy. I'm going to make a little note on here just because I'm going to post this up on the website later on the thing saying add, subtract vectors and scalar multiplication independent. You are good students. You can learn those on your own. You probably can learn all the other stuff I'm doing too. If anybody figured out really that every single thing that I do is up on the internet, and you really don't need me at all. But please don't tell everybody. I like my job. Don't want to lose it. So, what we are next going to do is we're going to combine. This is going to be the sixth thing. Combining vector operations. So let me give you two vectors and tell you where we're going to go with this. V equals -I minus 6j, and I'll use the vector W, -3i plus 7j. So we have those two vectors here, and we're going to do some things with them. So doing the multiplying and stuff is actually so easy, we might as well, that's why I'll do it here anyway, because it's part of this problem, but it's really easy. 4v minus 3w. So this means we're going to multiply 4 times v and multiply -3 times, or 3 times w, and then subtract. Okay? So what that will mean, let's actually just take it and put them in place. So really, one way to think about this is as a substitution. And then this one going in there. So it's going to be 4 -I minus 6j minus 3 -3i plus 7j. So just more of the same all at one time. Yes?
Where did the 4 come from?
The 4?
Yeah.
Oh, This is the problem I'm giving you.
Oh, okay, that's
Yeah.
a problem. Okay,
So no
thanks.
problem. I put A, but that wasn't enough. I'll circle it and then I'll help everybody. So I'm saying 4 times the first vector minus 3 times the next vector. So this combines multiplying and adding and subtracting. So here, what that means is we take the numbers here, because we know that's 1, so it becomes negative 4I minus 24J plus 9I, because I'm just doing distribution here, minus 21J, and then combine like terms. Think of them as like terms and just combine them. Okay. So we would do 9 take away 4 is 5I, and then lots of these J's, because they're all negative, but lots of negative ones, 45J. Now, one of the other things it does is does the magnitude of adding, multiplying them out, but I'm going to wait on that one because not that hard to do anyway. Yeah, nope. So that's just doing 2 operations at once, really. Not that hard to do with it. Anyone comfortable with that one? I want to get in at least one more thing before we end the day. There's a couple more ones. This one is slightly more complicated. The one complicated thing I'm not sure we'll get to on time, but let's see. We're going to find a unit vector. There's a specific formula for that, and here what a unit vector does, remember a position vector starts at 0, 0, just you move the vector so you start at 0, 0. A unit vector is like the unit circle. It has only a distance of 1. So that means the magnitude of this is 1. It goes in the same direction as a vector, but it has specifically a magnitude of 1. So I'll write that out. A unit vector, A, goes in the same direction as a vector, and second, has a magnitude of 1. Just like a unit circle has a radius of 1. So I want to take this vector vi minus, now I've got the minus right, minus 2j. And there's a little formula for the unit vector, which isn't that hard to learn or memorize. And it's going to be that you put the vector on top of the magnitude of the vector. You know how to find the vector. And so this isn't going to be that hard to do. Let's do it with this. Let's find the magnitude. And the magnitude is just the distance using x and y here. So it's going to be 4 squared plus negative 2 squared. So it's going to be square root of 20. And square root of 20 has a 4 in it, so it's going to be 2 root 5. So now we'll put 4i minus 2j over 2 root 5. And this is just like a regular fraction. We'll put the 2 root 5, since we can reduce here, we'll just put it on each of them separately, which we do need to. Notice at this point, if we didn't have I and j, if we had variables in there, other variables, that would be normal to just you leave it that way. But you have to have I and j in their own separate fractions. That's what makes the name of these vectors. So that means we have to do 4i over 2 root 5 minus 2i over 2 root 5, okay? And cancel the 2 into those, so we get 2i over root 5 minus I over root 5, or actually 1 root 5 over root 5 and I next to it, because it's the number and then the I. Anyone think something fishy here?
Oh, you did get the square root.
Exactly. You have to rationalize it. We can't leave a square root on the bottom. So we're going to have to multiply top and bottom by square root of 5. So it's 2 square root of 5. Oh, that's not I. Who's j? This one's got to be I. 2 root 5 over 5 I minus root 5 over 5 j. Now, see where I start doing this and I start forgetting that the I here actually is after the number, and the J here, I put I twice. I was so good keeping the J's and the I's in all the right places, and finally, right at the end, I got that one off there. So now I'll fix it. So that J should be afterwards, the I should be after, and we can deal with just the coefficient. So we get to here, and now we've rationalized it with 2 root 5 over 5 I minus root 5 over 5 J. Now we get it done. So the formula here is really pretty simple. It's just if you get a square root answer, you've just got to play with the rationalizing part.